So you see, now the productivity index is very close with the actual performance I get from well test data. Okay, so the absolute open flow, 7,000. So with the same method, okay, I want to construct IPR, okay, for the new reservoir. Okay, so let's go to new layer and I call it B layer. Okay, it's active and it's a limestone reservoir. So now let's input what I know about this reservoir. Okay, so the value is this reservoir temperature 180 and the mid perf at this location. And I know the permeability 243 based on well log. Thickness is quite thick, 80 feet. The same, of course, wellbore radius. Water cut, let's say, I know, I predict the water cut to be 97%. Gas ratio, 300. I want to construct, of course, using Vogel approach, 0.2. And I use calculated skin. Drainage geometry, 250. Or maybe based on that, 200. Okay. And skin modeling, case hole, limited entry skin. Okay, the nearest measured formation distance 1.35. So vertical permeability, maintaining 10% assumption, 24.3. Upper interval, 20 millidarcies. Deviation skin, 0. And the same configuration for the perforation, 3.3, shot density 6, and shot facing 60 using log equation. Okay. So 3.3, 6. Can save. You can go back to test data or maybe layer parameters. Skin, something wrong here. So that's why the perforation skin still none here. Just change it to, okay, so, oh, this one, this is error. So this is 1.35. Okay, so now you get the perforation skin, okay, and the productivity index 7,007, I mean 7.77. Okay, lower than the previous one, I mean the initial reservoir. And we get absolute open flow 3,400, and this is the total Darcy skin. Okay, so now I have two reservoirs. My existing reservoir, the T reservoir, and now I also have my target reservoir, the B reservoir. I want to combine the performance between them both, and I can show the composite IPR using this one. Okay, so very interesting. You can also show the legend here. So this one is the T reservoir, the performance for the T reservoir. And this one is for the B reservoir. You can see the T reservoir has greater reservoir pressure, so it's bigger in size and it has better quality. The PI, the productivity index, is 14, whereas you also have the B reservoir. It's actually not a poor quality reservoir. It's good reservoir, but the reservoir pressure lower and with slightly poorer quality. And if you combine them, if you perform commingle production, you will have this new IPR, the blue IPR. I can make it bolder, okay, just to appreciate it. Okay, so this is what you have if you perform commingle production. All right. Okay, so there is no risk of crossflow between the two reservoirs. So in general, you obtain a better performance. Okay, you get a better performance in liquid production perspective. We still don't know about the oil production perspective because we have different water cut. Okay, so that's it. And by maintaining the same configuration for the ESP, let's say we assume everything the same for the ESP, the pump stage, the pump type, the pump setting depth, okay, and so on and so forth. We just go directly to the analysis. We perform nodal analysis.